This lesson is going to be on inequalities. If you have ever gone to a theme park, sometimes it will say that you have to be at least a certain height to get on a ride. So they might say, you'll see a sign like this, right? And it'll say, you must be, you must be at least 45 inches. At least 45 inches to get on this ride, right? And they have a little measuring stick there that they measure little kids and stuff. That's an inequality. Can you be 46 inches to go on that ride? Yes. 47? Yes. 48? Yes. 44? Nope. You can't be 44. Can you be 45? Yes. You can be any number of things, but you have to be at least 45 inches. So let me show you what that means when we write it as an inequality. It means a person, I don't know who the person is, so I'll just have to say X. Anybody, has to be, he could equal 45 or he can be greater than 45. And that's called an inequality right there. That's just called an inequality. And by the way, with inequalities, you have, millions of answers. Okay? The first thing I want to make sure that you guys know how to do is to read these signs. I know that when you were in elementary school, they talked about the alligator and all that, but it just, you know what? First of all, I don't understand about the alligator. But let me just tell you this. I used to play piano, I still do. And we would be playing these notes, right? And we'd come to a place, and as soon as we got here, it meant we're playing really, really loud, and we have to go really, really soft. Starting loud, getting soft. In mathematics, we start big and we get small. So on this sign, I could put a 10 here, and I could put a 2 here. That means 10 is greater than 2, because there's the big part. 10 is greater than 2. I can say 2 is less than 10. Because look, this is the little part. It's right next to the 2. I read it from left to right. 2 is less than 10. All right, how do you read this? Think about this in your mind. Does that say bigger than or smaller than? 4 is bigger than. Because you start on the big part and you go to the little part. Guys, I don't want you to go any farther on this paper or on this little section until you can read that. If you can't read it, you can't do these inequalities, okay? So make sure you can read those things and don't let yourself fall from that. All right, so let's say that I say x is greater than 2. All right, we always graph these things. So let me show you an easy way to graph it. I will put a 2 here. I'm not going to color it in. And then I'm going to draw an arrow that's going to go this way because x is going to be bigger than, greater than 2. Now, when you see these, now there's one thing I should have done. I should have put a 2 there. A 2 and then an x. You do not have to make these things where you go 1, 2, 3, 4, 5, 6, 7, 8, and then put a circle there, and then, 0, -1, -2. You just don't have to make these long graphs. All you have to do is, number one, be able to read them, but then just draw the graph like this. Just make a line, put your number, whatever the number is that they're asking you to do, put it underneath. Let's say they're saying 3. Just put a 3. And either it's going to go less than or it's going to go greater than, depending on what the question is asking you. So just make the graph like that, okay? What if we would say how about if I say x is greater than or equal to negative 5? I'm going to draw my line. I'm going to put a negative 5 here. Now, because I have two parts of my inequality, I have a greater than and an equal to, that means I'm going to do two things. I'm going to make a circle, that's number 1, and then I'm going to color it in. That's number 2. On the last one, remember, we didn't color it in. Now, x is greater than, that means my line is going to go this way, and there's my x. X is greater than or equal to negative 5, and that's all you have to write on that graph. But you do have to be able to read them as well. Here's a little problem. What if I would say to you, which number is a solution to this inequality? Which number is a solution? In other words, is an answer to this question. If I say x is greater than 4.7, well, first of all, there's a million answers. There's an infinite number of answers. But can you think of something? What number is bigger than 4.7? Could you say 5.6? Yep. Could you say 9.3? Yes. Could you say 4.6? Nope. As a matter of fact, could you say 4.7? Nope. It has to be greater than 4.7. So one of the solutions could be any number of things, but it couldn't be those. It has to be greater than. What if you have a question like this? C minus 3 is greater than or equal to 2. The way you solve this equation, you solve it the same way you would if you were just doing a regular math problem like this. On this one, I would go plus 3 on both sides, plus 3, cross that off, and C would equal 5. That's how I would do that problem. See that? This problem with the inequality, you do exactly the same way. You go plus 3 on both sides, plus 3, C. Now you write down the inequality is greater than or equal to 5. And then when we graph that, we draw a straight line. We put a 5 here. We put a circle. Are we going to color it in? Yes, because there are two parts to the inequality. So I'm going to color it in. And it says, now see, you have to be able to read this. If you can't, you'll draw the arrow the wrong way. C is greater than, because look, here's the big part. Here's the big part. C is greater than or equal to 5. So I'm going to draw my line going this way, going up. Okay? Sometimes you'll get a problem like this where they're asking you to write down what the inequality is. Well, let's go ahead and use, X for the number. It doesn't really matter. Whatever letter you want to write is fine. We're going to start with the letter X, and we're going to say what? What's happening here? Is the line going down or is it going up? Well, it's going down, so that means less than, right? But is the dot colored in? No. So it's only one thing. It's only one inequality sign. And we say X is less than negative 7. That's the equation for that graph. Okay, so you just look at two things. You look at how is the line going. Is it going up or down? Then you look at the number, and you look at the circle. If the circle is colored, in, of course, then you have to put that other sign there as well, the equality as well. Okay? Here's an example. When they give you words and you have to put it into an equation, it says you must be at least 51 inches tall. Well, let's start with x again. That can be you. You must be at least. Now, right away we don't know what at least means, right? But think about it. If you say at least 51, say to yourself, could you be 52? Yes. Could you be 53? Yes. Could you be 54? Yes. Could you be 51? Yes. Could you be 50? No. All right, so all of these numbers then are what? Aren't they bigger than 51? So we have to say that x has to be bigger than 51. Can it be 51? Yes, it can be, so I can also put that down. So x has to be greater than or equal to 51. Okay? What if I said you have to be at most 51 inches? At most. Could you be 51 inches? Yes. Could you be 52 inches? No, you can't be 52 because 51 is the most you can go. So anything, can you be 53? No. Can you be 54? No, they're all bigger. But can you be 50? Yes. Could you be 49? Yes. So in this case, x can be less than 51. Can it be 51? Yes. So it can be less than or equal to 51. So listen, these are the two that always give kids the hardest time. At least and at most. So I'm not going to ask you to try to memorize stuff. I'm just going to say to you that when you get to a problem like that, say to yourself, can you be the number? Can you be more than the number? Just ask yourself the same questions I just asked you. What if I tell you to write an equation that would work with this? Below 15 degrees. X something 15 degrees. Can it be 15 degrees? Can it be 15 degrees? No, it has to be below it. Can it be 14 degrees? Yes. 13? Yes. 10, and so forth. So x has to be what? Less than 15 degrees because it can't be equal to it. So that's my inequality right there. The last two things that I want to talk to you about for inequalities is multiplying and dividing inequalities. And again, you do it exactly like you do regular algebra. You have a number 2 times a letter is greater than or equal to 6. To solve it, I want to know what m is. I don't care about anything else. So I have to get rid of the 2. So I draw a line there and put a 2, draw a line, put a 2. This goes away, and I have m is greater than or equal to 6 divided by 2, which is 3. Guys, always use your calculator if you don't know. But remember, when you put it in the calculator, you do it like this, 6 divided by 2. You always put the one on top first. And this is really a division line. This little fraction thing here is a division line, okay? In any case, that's the answer. Now, the only thing that I have to show you is this. However, if I say negative 2m is greater than or equal to 6, now what am I doing? Everything I'm doing regular again. This is just an algebra problem. But I'm dividing by negative 2. Negative 2. Now this goes away. M is greater than or equal to, and I divide this, negative 3. But here's the problem. When I'm dividing by a negative sign, I have to switch the inequality as well. So it has to say this. M is less than or equal to negative 3. That's the answer. You have to remember when you're multiplying or dividing with negative numbers, on the left side, not on the right side, on the left side, that you have to change the inequality. Let me make sure I've said that okay. So let's make sure I just said that good. Watch this. If I use this for a question, 2m is less than or equal to negative 6, I'm going to divide by 2. But guys, I'm not dividing by a negative 2, and I'm not multiplying by a negative 2 on this side. I'm dividing by a positive number. So m is less than or equal to, but when I divide it, it will be negative 3. But I don't change the inequality sign. The only time I change this sign right here is when this number is a negative. I hope that's not confusing. And the last one that I want to show you is x divided by 2, and it's this is a negative fraction, so basically we can say x divided by negative 2 is greater than 5. All right, the first thing I have to do is get rid of the denominator. Whenever you're doing any kind of algebra and you have a denominator, you have to get rid of that denominator first. So to get rid of division, I multiply on this side by a negative 2, and I multiply on this side by a negative 2. That goes completely away, and now I have x is greater than 5 times negative 2, which is negative 10. But here, because I multiplied by a negative 2, then I have to switch this inequality, and it's going to be x is less than negative 10. Okay? All right, now I want you to do the practice paper that's coming up. And when you're done with that practice paper, bring it back to me. Write all the problems out. I don't want you to just put the answers, okay? Copy all of these problems down and then turn them into me. Thank you, guys.